Good morning, Bears. All right, it is a Tuesday, and I think we're diving into some data today. But before we do that, let's take a look at a slideshow. It sure is nice when somebody gets all their work done so quickly that I can dive. Remember, we're in a science week. If you have not opened your slideshow yet, go to courses, go to science, look to the right, intro to climate, click it. Then yours looks different from here, but you should be able to make sure to open the slideshow because that's always helpful. I am probably going to use Emma's a lot or other people in period 2s now because I do the lesson before the other classes even get it. Now notice this submission is blank. It should be blank because we just started. If this was a history I'm looking at, submissions should have your name. So if you go into your history from last week and you have not submitted things, go submit it. Let's look at it in progress. Melody, you need to get yours open. Jordan, hey, Jens, you were in class. I think you're at school. Get your slideshow going, buddy. Louie, get slideshow going. Angela, I think you opened it, but I don't know about work yet. I'm going to just cruise down here and let's check Emma's. Well, I did Emma's last week. Let's see if Krill's got hers done. She's usually on check. Look at this. Beautiful thing to work with already. I'm going to open it because it works better. We're dealing with climate change. She has a title. She will put her name here, Climate Change by Kirill. Just do first names because that way when I post these on videos and stuff, people don't have to know your last name. Then we come down here. This was Monday's lesson. This is in groups. It's also here. If you're behind or it's a Tuesday and you want to catch up, you can go and watch those. Notice what she did. She took the concept and she added a visual. Now the visual is the goal of the visual is to help you understand. So you look at the visual and say, what's going on there? I see an arrow, I see a map. Then you come down and read overall tendency. Now maybe you don't know what tendency is. You can highlight it and you can click thesaurus, I think. And it'll even show you. You can click dictionary. It would show you what tendency means. For example, a consistent increase in a set of data over time. We're going to be dealing with data. So a trend, like it gets warmer today, it's warmer tomorrow, it's warmer the next day, that's a warming trend. And they're using a map to show that. We come to fluctuation. What does fluctuation mean? Variations in a set of data. Now, once again, here's that word data. Data is when you get information like temperatures, or let's take a look at a picture. Once again, let's look. Oh, here's a river. This looks like the river. The zone of intermittent saturation, summer water table. It's dry in the summer. Unsaturated zone in the water. So it's dry in the summer. Here's the river. So the lines down here, dry, river in the winter. And this is the aquifer, which means water under the ground. So there's a fluctuation. It means it changes. Today's 80 degrees. Tomorrow's going to be 90. That's a fluctuation. Beautiful. Climate. Now, we all kind of know about climate because we did a whole unit on climate. Climate is not weather. Climate is regions that have, in general, the same type of temperatures. And this map shows it. So warmer temperatures, colder temperatures, really cold temperatures. And here in Southern California, where we are, we have a moderate, if not a warm climate. In general, it's nice and it's warm here. Climate change, you can figure that out. Oh, and I didn't even read it. General weather patterns over a long period of time. Climate change, well, hello, the general weather periods start to change. Once again, it's not weather changes, although it does impact weather. Weather's more extreme, like floods. But a climate is more like, for the last 10 years, in general, the fluctuation of our temperatures in California, I'm just making this up, is 70s to 90s. Well, all of a sudden, if you look back in the 10 years before that, the average was 65 to 85. Then we'd say there's a warming trend in our climate, and the fluctuation is in a different gap, using all our words together. All right, so that gets us warmed up. So everybody should have something like this up until this point. All right, let's dive into our lesson today. You'll see I put a little slide here. Tuesday lesson starts here. See groups. You can get rid of that slide if you want now, but let's get started. Here's a claim. Remember CERs, claim, evidence, reasoning. The amount of ice at Earth's poles is decreasing significantly. Here's a claim related to ice on Earth melting. Your first task as a student climatologist is to review data about this claim. It's important to be skeptical and look at the data carefully. That you want to do that everything. You hear something on the news, skeptical means you trust nothing, verify everything. I'm telling you, in this day and age more than ever, do your own research if it's something that matters. Some scientists didn't agree with the claim that an increase in global average temperatures caused ice to melt. At first glance, not all the evidence seemed to support this conclusion. You and your partner will examine graphs with data about the amount of sea ice. Now, whenever you see something like those graphs, take a quick glance. Now, they're going to show us this 10 more times, but remember, this is the vertical axis, and that's otherwise known as, I got to make sure, it's been a while since I've missed these. I think in math you're talking about the y-axis, and this is the horizontal axis, which is the x-axis. So if you saw a number 2, 3, the x would be 1, 2, the y would be 1, 2, 3. You'd put a dot there. But for now, just remember vertical axis, y. What's the vertical telling us? Million square kilometers of ice. And then this is the time. Usually the time goes along the bottom. Look at here, 2002 to 2014, 1880 to 2020. We're going to make these graphs in our slideshows today. So start getting used to it. Amount of summer sea and ice in the Arctic. Amount of summer sea ice in the Arctic. So both the same topic. One's 1870 to 2013. One is 2002 to 2013. So this is a little bit different. Look at the time. This is what? 1880, 1980, 140 years. And this is only 8 years. And then this is the same numbers though, 4 through 9, 4 through 9. So you always want to compare charts like that. Get an idea before you start going. When you are reading, it's important to pay attention to the titles and axis labels. I just did that for you. Go analyze the climate page. Go to the Analyzing the Climate Data page. Examine the graphs with your partners and discuss the questions. So the Analyze the Climate Data page might be here. Let me see. Sometimes they're in here. I don't think they are. I think they're talking about these, which is the same as these. Notice, much easier to see them here. And so we're making this work because you're not in class. Here's the questions, but remember, if you want to see them clear, there's the charts. So here's what we want to do. We're going to talk about this. I'm going to throw you into breakout rooms. We're going to try this today with a partner. And hopefully your partner, I think I'll go 3 people. Let's try to go 3 people. And let's hope 2 of the 3 can actually analyze. Remember, you need 2. If you're by yourself, don't worry about it. Just answer these questions. But if you're with your partner, before we answer them on paper, I want you to make a window so you can see this, your slideshow, or you could pause the video, and you need to be able to see this. And then you want to be able to see these questions, which are here. Now, I'm going to make this bigger. You can do the same. Remember, you can do this in your slideshow. This is in your slideshow. Make this as big as it'll kind of work. And if you put it on present, you can read it. Here's our questions, and I'll let you go in. And I want you with your partner, read them, look at the data, talk about it. Now, if you have the ability, you got your skills going, you can actually start answering these. Now, when you answer these, you cannot highlight these texts because it's a thing. So you just have to say what information is provided in graph A. So over here, you can get rid of this. I'm not going to delete it here because it's in a slide. Click that, delete it. That's the best way to do it. So question 1, what information is provided on graph A? Put a 1 and write your answer. Now what I'll do, instead of deleting that, I'll just make a text box, which you guys can do as well if you ever wanted to. And so I just put 1. What information is provided on graph A? You and your partner look at graph A. What is it telling us? And then you do the 2. What can you conclude about the amount of summer sea ice in the Arctic based on graph A? That's a conclusion. What is the conclusion? What information is provided on graph B? What can you conclude about the amount of summer sea ice in Arctic based on graph B? And then why do you think some scientists initially disagreed that the overall ice was decreasing? So a little bit challenging. Do it with your groups. See if you can come up with the answer and write your answers here. I'm going to give you about 5 minutes in groups Then we're going to come back, talk about it again in Zoom. If you're not in Zoom, you just do the best you can because you won't get those answers. And then we'll write it here, 1 through 5. So this is one of the big things we're doing today for A-level people, 1 through 5 here. All right, go to Breakout Rooms, 5 minutes. Let's do this. Back from Breakout Rooms, let's take a look at our findings now. You will get the answers now. So if you did not get this completed, it's okay. But after we go over the answers, I need you to come back and complete this and move this to top slide. So everybody should have this and 5 answers here. Now remember, you can delete these things. You'll have plenty of room. You're going to delete both of these. So you're going to have a nice big text box to answer these questions. That's the main assignment for today. So let's go look at the answers. This is another piece of climate data on the global average temperature. It also shows a pair of concepts that are important in earth science. In earth science, it's important to have a data from a long enough time period to tell if there's an overall tendency or if you're just seeing variations. So trend, overall tendency for an example. So notice the trend is up. Yes, there's fluctuations. It varies, but look, the trend is up over time. This is global average temperature, 1880 to 2009. One of your graphs. Now look at this. This is temperature. Notice, this is different than this. This had ice melting. It had numbers. Let's go up here. Remember, this had numbers, 4 through 9. So always pay attention when you check a new graph. Is it telling me the same thing or not? No, this is now temperature. This graph shows temperature changes since 1880. The temperature goes up and down a lot, but the tendency or overall change is an increase in global average temperature. If you only looked at the data from a shorter time, for example, from 1945 to 1950, you might conclude that temperature decreased, but that is just a fluctuation. Notice going up, fluctuates down, going up. If you follow the larger trend, which you can see by following the blue line on the graph, you see it shows an overall increase in temperature. So notice all these fluctuations, what you do is you end up drawing a line across the center point, and then that gets you your tendency. Graph A shows fluctuation in the sea ice data, but if you look at a longer period of time on graph B, you can see the trend is an overall decrease in sea ice. So notice graph A, and this is answering our questions, shows fluctuations in sea ice data kind of trending down, but kind of similar. Over here, you see a stronger trend down, a decrease in sea ice. Remember, climate is the weather over a long period of time. The climate change refers to the ways that climates and regions on Earth change over long periods of time. To explain something happening to Earth's climate, climatologists don't just look at the weather over a few days, months, or years. Climatologists need to look at longer periods of time to form these explanations. Trends and data show what's happening over long periods of time. We saw this, bouncing, 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 trending up. The data on the graphs lead us to this key concept. Although there are many fluctuations, there is a trend toward increasing temperatures and decreasing ice on Earth since 1880. We see that here. Look at 1880, trending down, temperature going up. So what do we have? Temperature trending up, ice levels. This is how many millions of square, how much ice there is, less ice. As the temperature goes up, there becomes less ice. Kind of obvious, right? We learned about that before. Hot things and cold things. The cold is going to get moved away from the heat, or the heat's going to move into the cold, and they're going to balance out. So if you have hotter temps, you're going to have less ice. Although there are many fluctuations, there's a trend toward increasing. Saw that, we already read that. We found evidence of a trend that has been happening since about 1880. Temperatures are increasing and ice is decreasing. Coming up, particular attention to energy, because temperature and melting ice are related to energy. What is energy? Remember this, the ability to make things move or change. What's this? Remember that energy is the ability to make things move or change. The change we're investigating is a decrease in ice and an increase in temperature. Temperature, a measure of hot or cold something is. What do we have here? 2 new concepts that we need to move to the top. All right. So this leads us to the big question that we're not going to answer today, which is what could be causing ice to melt? Temperatures rising, but the temperatures to increase. So it's pretty obvious, I think temperatures increasing causes ice to melt, but what's causing the temperatures to increase? Do not answer this right now. That's tomorrow. We will dive into a sim. So what's your bottom line today? Move this and this to the top. Add your visuals. Come back up to our slide that had our questions. Where are they? Right. They have the sheets. This is the easiest way to see them. And you need to answer these questions. Now, we just answered them. So if you were paying attention in the video, if you want to go back or just go scroll down, every one of these is answered in these lower slides. All right, let's get busy. This needs to be moved to the top. Create a text box. What information is provided in graph A? I look at A and I say amount of summer sea ice and changes. I just did one for you. Now go do 2, go 3. Think about it. You talked about it in your groups. Finish this slide. Move it to the top. Tuesday. Kind of an epic. All right. Have a great day, everybody. Talk to you soon.